you will begin your final project, okay, for recording, okay. And as I draw on the board, analysis of variance pronounced as ANOVA, okay, ANOVA, okay. Concept, and actually I put the table 4.1 to 4.4 on the Moodle, okay. So for your benefit, I still put right here, okay. And in Chinese, called 实验单位, English is called experimental unit, okay. So you guys on a biotech, you have to do the experiments, right? So this is a terminology in the experimental design, okay. That's called a pen out, okay, right here. Second one called a dependent variable, okay. In Chinese called 一变数, dependent variable. They have a lot of wording, but do remember the dependent variable is a y, okay. Sometimes multiple dependent variables, they are like a y1, y2, and yp, okay, variables, okay. And this is the outcome variable or result of the experiment, okay. Outcome variable or result of the experiment. So when you discuss this later, we will talk about GLM family, okay. The full name is the general linear model, okay, general linear model. But do remember the dependent variable is classified as y, okay, y1, y2, and yp, okay. And factor is the independent variable, okay. One is dependent is a result, independent variable is the cause, or we can say that influences the dependent variable, okay. Generally, it is a qualitative variable. So in chapter 1, you have to remember NOIR, okay. So for factor, normally is about the NO data, okay. Nominal ordinal data, okay. So called a qualitative variable, okay. Right here, qualitative variable. Depending on its nature, right here, qualitative variable, okay. Depending on its nature, it can be further divided into controllable and uncontrollable, okay. Fixed and random, okay. Cross and nested, and quantitative and qualitative factors, okay. Quantitative and qualitative, okay. Quality and quantity, okay. Numbers, okay. Quality. So such as the nominal, okay. Your student ID, right? And all the freshmen, sophomore, junior, senior is ordinal variable, okay. Level 中文叫水准 level. Sometimes they will say 你没有水准. What's that mean? 你没有水准什么意思? What's that mean? Level is a 水准. 对。你没有水准有没有？说迟到没有水准啊？ Let's check out a good friend, okay? Called a Google Translate. Remember, 水准 is a level, okay? Level. Translate. 你没有水准 in Chinese, they have another meaning, okay? That's Chinese 没有水准。Let's check out English first, okay? Let's say no standard. Actually, 水准 is a level, right? So if you see the PPT right here, 水准 level, right? That's another meaning in Chinese, okay? That's 越南文。
Không có tiêu chuẩn.
What's that mean? Is someone can tell me? 没水准. For example, if you go to the movie theater, everybody stay in a line, right? You cut the line, they will say 你没水准. Is the same meaning right here? This is different meaning. You cut the line. Everybody put a line to buy some food, buy the ticket, and you cut the line, they will say 你没水准. So it's a different meaning. 没有礼貌. 没有礼貌. So it's not this one.
không có tiêu chuẩn.
No, okay. Okay, so it's a different language, okay? And remember the terminology, they have a 4 right here. The level is a different settings within a variable, okay? For example, male and female is a 2 level for the gender, okay? Freshman, sophomore up to the senior is a 4 level for grade, okay? Understand? So if the question asking how many levels within the university grade level, you have to reply as 4, okay? Reply as a 4. Last one is the treatment, okay? Treatment is in experiments within multiple factors, okay? It is a combination of different levels among different factors, okay? Very important, the terminology, especially for the experiment, especially for the biotechnology, okay? Because you guys will do a lot of experiments, right? Okay, this is a basic ANOVA table specification, okay? And normally in my formal department, we will ask the students to calculate. So that will be a lot of formula, but right now you don't have to worry about it. But do remember this is a basic ANOVA table, okay? On the first column called source, okay? There are 3 kinds of source. First one called regression, okay? Regression. Right here. Error, okay? Total. So if it is a sum of squares, they will abbreviate it as the SS, okay? If it is in regression, they call it regression SS, okay? Error SS, total SS. Does anyone know the formula? The 3 right here, the formula. So sometimes they will call it SST, okay? Is anyone can tell me what's the relationship between the SSR and the SSE? Anyone look at the table right here can tell me the formula? And this is a degree of freedom, okay? Degree of freedom. What's 1 plus n minus 2? 1 plus n minus 2 is n minus 1, right? So the formula is this one. Please do remember that. SST equals SSR plus SSE. Okay, understand? The degree freedom is 1, right? 1 plus n minus 2 is equal to the n minus 1. Okay, so that will be the 1 here, n minus 2 here, degree of freedom. Okay, this is n minus 1. Okay, so please remember this formula right here. Okay, and for the if SSR, okay, divide by 1 is a regression mean square. They also call it MSR. Okay, MSR. So you guys are smart enough. This one is called MSE. Okay, MSE. Understand? Okay, MSR, MSE. Okay, and it is divided by the degree of freedom, but we have detail. Okay, detailed ANOVA specification. Okay, so if the source will be like, they have a formula right here, but I already put right here. Okay, so they call a model. Okay, model degree of freedom still below 1. Okay, error and -2. This is a detail. Okay, and -1. You see a formula right here. Okay. But the formula for this one is the summation. It's called a hat. Okay, H-A-T. Hat. Read hat. Okay, like a gentleman wear a hat. Okay, hat mu I minus y bar. Okay, square. And SSE equals summation of yi 减掉 minus yi bracket square, okay? And SST equals summation yi minus y bar bracket square, okay? And for the mean square, the MSR is equal to SSR minus 1, okay? MSE equals SSE minus the degree of freedom here, okay? And minus 2. Actually, this is the variance, okay? Variance, SS squared. And for the experiment, they have a F value, okay? F value is MSR divided by MSE, okay? So formula is right here, okay? SSR minus 1 minus S squared, okay? So this one divided by S2, okay? S2 means the variance. That's a table 4.3. And move to the table 4.4 called the GLM family model function, okay? So that formats, okay? Abbreviation and the notes, okay? So normally in the SPSS, the red color will be the crucial one, okay? For example, y equals FRA called a one-way ANOVA, okay, one-way ANOVA. So they only have one dependent variable and one factor, okay. For example, A is the qualitative data, okay, like gender, okay, and Y may be the linguistic intelligence, okay, and just one dependent variable and one factor. And you have to note the significance of p-value, okay? And the pairwise comparison when I greater than 2. Remember the I is called a level, okay? I is called a level, okay? Male, female, and others, they have a 3 level, okay? Grade level, freshman, sophomore, junior, senior, that's 4 levels. So when it is a greater than 2, okay? You have to make a pairwise comparison, okay? If they have one more factor called a B, okay? B, they call it as the two-way ANOVA. So the way is the factor, okay? Two-way ANOVA. So also you have to note that the significance of p-value, okay? Pairwise comparison when I greater than 2. Because they have 2 factors, so you have to beware of the interaction, okay? Interaction. So let me ask you a quick question. Can a female alone have a baby? Can female alone can have a baby? No way, right? They need to have a partner. They have a have a baby, right? Otherwise, it's kind of called artificial, right? Artificial injection, something, okay? And this is the 3 factors, okay? So it's the same, okay, as the 2 factors, okay? And in the thesis, I mean, this one is very common, okay? Very common. So they have multiple dependent variables, okay, and one factor. So you have to know how to read it. It's called a one-way MANOVA, okay? ANOVA means the multivariate, okay, multivariate. So when you have to do the multivariate testing, okay, and pairwise comparison when the level greater than 2, okay, multiple. So on the left hand side, your multiple y's, okay, multiple y's. Okay, so they need to deal with the multivariate testing, okay? And remember, they have two factors, they have interaction, okay? Interaction. So everything, the level greater than 2 for the factor, they have to do a pairwise comparison. And I will teach you how to make a judgment, okay? So this GLM family model function is very important, okay? That dealing with a lot of kinds of differences, okay? And I'm not sure that, you will do what kind of experiment. Maybe this is a place you can check it. Validate, okay? You can check it which analysis you want to use it, okay? And if they add up like a x variable, the name is change the code, okay? What's the code? Code means the covariance, okay? Covariance. And you see they got the S1, S2, SK, their code, okay? If on the left hand side is multiple, they call the Mankova, okay? So call the Mankova right here. This is Mankova, okay? So they have a covariance. But you do need to make a note, okay? You have to know something like p-value significance and level greater than 2 need to do a pairwise comparison. Okay, if they have 2 more factors, okay, you have to be aware of the interaction, okay, interaction, okay. This table very important, okay. Let's look at the one-way ANOVA. Remember, I mentioned about at least 3 times. Table 4.4 GLM family model is very crucial, okay, very crucial. Crucial is more important than important, okay? And this is a testing procedure for a one-way ANOVA, okay? Normally, they have 6 steps, okay? In the first step, they have known hypothesis, okay? H0, okay? H0, okay? All group means are equal, okay? If you set out the known hypothesis H0, that means all group means are equal, okay? And alternative hypothesis called H1. That means this one group mean is different, okay? And second step, calculate the sum of squares. Calculate sum of squares. So in a table, we already got the formula, right? SST equals SSR plus SSE. E means error. Regression means the model, okay, model. So SSR is the variation due to the model, sometimes called between groups, okay, between groups. E is the error, is a validation within groups, called residuals, okay, residuals. SST is the total variation in the data, okay. Number 3, compute the mean squares, okay. So if you don't want to get the headache, you can go back to the detailed ANOVA specification table here, okay? That's number 3, compute the MS, okay? They have a formula right here. Actually, it's the same as the table, okay? Number 4, calculate the F statistic, okay? F equals MSR, okay, divided by MSE. Okay, or you can say MS the model divided by MSE. And you will compare the F value to the critical value from F distribution table, okay? So normally in the stats, you have to check out the appendix. They have a table to check out the F values, okay? And number 5, determine the significance and use the p-value. P-value sometimes they call the computer value, okay? And you'll find it on the SPSS. And you will use the p-value to assess whether to reject the known hypothesis, okay? Reject the known, that means at least one group means the different. So, like I say in the chapter 0, right? Although it is a Chinese, okay? You have to know the secret tips for the statistical analysis. First one is dealing with the present situation or status quo. So that will be the last week we mentioned about chapter 3, right? One is called the frequency, one called the descriptive. Second tip is about a difference, okay? This is ANOVA. Chapter 4, ANOVA, okay? So in here, you will use the p-value, okay, to whether it is reject the known. The other saying is accept the H1, okay? If you reject the H0, you will accept the H1 right here. That's the one set, okay? One set. Okay, the other saying means you accept the H0 and reject the H1, okay? And that will be based on the p-value, okay? P-value. And this one is important. If you choose alpha like 0.05, if the computer value p less than alpha, that means reject the non-hypothesis, okay? So the conclusion is the significant differences existed, okay? Exist. So it's a single, you can say it is a significant, okay? And number 6, called a post hoc analysis, if needed, okay? If I is a level greater than 2, more than 2 groups, you perform the pairwise comparisons, such as the Tukey's HSD, okay, to identify which groups is different. Okay, the other one is called the Chauffeur, okay, that's CHEFFE, Chauffeur, especially when the level number is different. For example, the male like 111, female like 99, okay, total 200, right? So the level is different. The chauffeur maybe is good than the Tukey's HSD, okay? And don't worry about that. I put the English on side, okay? 总检定, this is the overall test, okay? And this is a picture, maybe better than the words, okay? Remember from the overall test, okay? If the non-hypothesis is non-significant, the test stop, okay? Test stop. If accept the alternative hypothesis, you have to remember H1 means the alternative hypothesis, okay? The other writing is HA, okay? H is take the name, the alternative, okay? HA is okay too, okay? H1, HA is the same thing, okay? H1, HA is the same thing, okay? And if it is significant, you have 2 choices, okay? Okay, on the left hand side, you will do the pairwise test, okay? Pairwise test. On the right side, you will do the contrast test, okay? Contrast test. They also have a conclusion about the accept the known hypothesis or accept the alternative hypothesis, okay? And finally, we'll make a conclusion right here, okay? That's a testing procedure for one-way ANOVA, okay? Oh, let's check on the SPSS. They have 2 passages in the SPSS for ANOVA, okay? One is under the analyze, okay? And compare means, then you can find a one-way ANOVA right here. That's one first path. Okay. Second path is under the GLM family. Okay. GLM, a general linear model. Analyze GLM and choose the univariant. Okay, univariant. And later on, we will do the SPSS operation. Okay, so maybe you need to do some work. For example, we will please follow the PPT right here. Okay, in the first process, you will create a Y variable. Okay, called a logical mathematical, and you can abbreviate it as the LM variable. Okay. And second process, choose an A factors in table 4.4. And you guys later can choose the sex factor, okay? And last step, we will do some operation and interpretation, okay? And okay, the process is such as you just follow my steps right here, okay? Analyze GLM univariant and create the logical mathematical dependent variables. Okay, choose the sex fixed factor. Okay, and choose the post hoc. Okay, and you ask a sex on the right side to the right side, and chauffeur. Let's read there's a chauffeur right here. Click on the chauffeur, okay? And click on the options, okay? And choose sex, okay? And click on the compare main effects. And when under the display, you choose the discrete statistics, okay? That's the result right here, okay? When you leave today, I hope you can finish the, same thing I did it right here, okay? So you will see the first one is about the warnings, okay? Because the post-hoc tests are not performed because of sex, because they have less than 3 groups, okay? So they have one warning right here, okay? And between subject factors, male is like 430, okay? Female is 418, okay? And we click on the discrete statistics, right? So can you tell me male is greater than female or female greater than male? Which one is greater? Male, yeah, male. But you have to make a judgment based on the, the p-value, okay? P-value, okay? And this is same as the ANOVA table, okay? I will teach you how to read it, okay? Intercept, okay? Intercept, if it is significant, it's not good news. It will reject your non-hypothesis. Data, the samples not equals your model, okay? The non-hypothesis is model equals sample. So normally, 80–90%, if it is a large sample, the intercept will be rejected. And why it is rejected? Anyone can tell me why it is rejected? This is a p-value right here. Why it is rejected? The answer is right here, okay? Answer is right here. P less than alpha, okay? P less than alpha is right here. P less than alpha. P, okay? Alpha 0.05 reject the non-hypothesis, okay? So they have a significant differences, okay? So let's back the result right here. Result right here. For intercept, let me try to write down the hypothesis right here, okay? Known hypothesis is the model, okay, equals your data, okay, equals your data. And alternative hypothesis, you can type the H1 or HA is okay. That means the model is not equals data. D is the data, okay? So the p-value is 0.00, okay? Actually, it's 0.00 and 0, very small number, but they just use the 3.00. That means the p-value is very small, okay? Very small. So if we choose alpha equals like 0.05, right? 0.05, that means 5% alpha level, okay? 5% alpha level. Because it's a two-tail, okay? Two-tail. Last time we mentioned about the bell shape, right? Normal distribution. So if it is two tails that were on the two sides, if it is 0.05, what's the rejected area right here? What's the rejected area? It's a 0.05 divided by 2, so it's a 0.025, okay? 0.025. So on the right hand side is alpha divided by 2, okay? This also is called rejected area, okay? Alpha divided by 2. So alpha equals 0.05 called level of significance, okay? So let me ask one quick question. The two tail, this one add up together is like 5%, right? 5% is a 0. Normally they didn't write that 0 out, right? So it's a 0.05. So 0.025, 0.025 actually is the same as the 5%, okay? They have two decimals. So let me ask you a question. If the total is 100, okay? What's the percentage right here? You hear? Percentage right here. What's the percentage? What's the percentage in this big area? Actually, is 1 means 100 divided by 100, called 100%, right? So they got the 5% here, so minus here. So in here, very simple answer, 95%. Okay, 95%. So the 95% called a level of confidence. Okay, confidence. And for this rejected area called a level of right here, significance. Okay, significance. So remember when it is 0.000 is less than 0.05. So reject the none, okay? Reject the none. That means the model is not equal to data, okay? You reject the none, you accept the H1, okay? Understand? Reject the H non hypothesis, you accept the alternative hypothesis. So that means the model is not equal to data, okay? But for this right here, the importance right here, okay? Sex is a significant. That means they have a clue. Maybe the male is different with the female, okay? Male is different with the female. Let's check it, okay? And let me ask you a quick question. If you don't have a descriptive table right here, can you make a judgment right here? Male is bigger or female is bigger? for mean, okay? Male minus female is 0.413. Is male bigger or female bigger? Male bigger. But don't worry about it if vice versa. Female minus male is a minus right here, okay? So it's a significant right here, okay? Significant right here. So you can make a conclusion as well. Oh, I didn't give you an answer, okay? Can you explain? Can you explain? So significant is very crucial. Let me give you an answer, okay? Don't put the wrong way. So actually the conclusion is male. For my study, okay, like 800 something, right? Sample is 800 something. For the logical and the mathematical, male is better than the female. Do you agree with that? Especially for your female, did you agree with that? Male is better than female on the math, logical intelligence, math intelligence. Okay? I give you an answer. A male greater than female. Okay? Or you already got an answer, this one. Okay? Intercept. Okay? Remember D equal not equal to the model. Or you can say model not equals data. Oh, it's the same thing. Okay? And okay, so P equals 003. It's less than 0.05. Normally in a stats you will give a 1 star, okay? 1 star, okay? 0.05. The 2 star is like a 0.01. Okay, 0.01. So 3 star, this is a 2 stars. Okay, you can give a 2 stars. If the 3 stars is like a 0.005. So let me ask you 0.003. How many stars? Right here. How many stars for a table right here? This one. 0.005, 3 stars. 0.003 less than 0.005. So you can give us 3 stars. Okay, 3 stars. For sure. Okay, for sure. So let's go back to that page. Remember, 1 star 0.05, 2 star 0.01, 0.005, 3 stars. Okay. Our result is a 0.003. 0.003 less than 0.005. Okay. So that's the 3 stars. What does that mean? You can say it is a very extremely significant. Male greater than female. Okay. Remember my samples including the Taiwanese and Chinese, right? So, okay. A picture worth 1,000 words. Okay. I think it's too long. Okay. So let's make a record.